Now let's do problem 510 from chapter 5. It's got a cantilever beam. And so what I want to do is draw my free body diagram. The black line is my beam, and then everything's measured roughly along the center of the beam. And then my response, it's a cantilever, so it can have X and Y. I call them R for response, X and Y. And then it can also provide a moment response. So we can't rotate it either. So MR, I'm going to take positive as counterclockwise. So I assumed all of them are positive, so I drew it counterclockwise. I called it MR for response. Those two angles are equal, so to sort of keep track of which one I'm using in the equations, I call them alpha and beta. And I didn't put all the distances because the diagram's right there. So first I said, let's take the moments about A, because that gets rid of Rx and Ry. Now, it doesn't get rid of MR. In fact, MR is the first thing. But the 6 kilonewton is 1.5 away. It's clockwise, so it's negative. Then I break this up into its X and Y parts. The X part's going to be cosine alpha, so 4 kilonewton cosine alpha. And then that'll be the perpendicular distance, so that's going to be 1.5 sine beta. And that would be clockwise, so it's negative. And then the vertical part would be sine alpha. And then the horizontal distance will be from here to here, which is 3, plus this distance, which would be 1.5 cosine beta. And then if you simply do the, that's equal to 0. So if you do the algebra solve for MR, I get 20.2 kilonewton meters. And then you sum the forces in the X. There's only two. There's Rx and then the 4 cosine. Solve for Rx and you get it's in the negative direction. I got a negative, since I assume they were positive, means it points in the negative direction. And then you sum the forces in the Y. You got Ry up, you got 6 down. You got the vertical part will be down here. It's opposite alpha, so it's sine alpha, 4 sine. Again, you solve for Ry, and I get 8. And then I wanted to check it, so let's take a moment about the bend. So this time Rx won't have a moment because it'll have 0 moment R, points through that point B. Ry will be clockwise, so it'll be minus, and I think that's 1.5 volts, so it'll be minus 3 Ry here. The 6 would be clockwise, so minus 6. Well, we're doing around the bend, so it's here. Wait a minute. That one would be counterclockwise. That one would be clockwise. This one will be counterclockwise. So it's positive, and it's 6 and 1.5. Okay. And then the 4 kilonewton, it's X and Y parts. I did the cosine first, so that's the horizontal. It's going to cause a clockwise torque, so it's negative, and its vertical distance will be sine beta. The horizontal times 1.5 sine. And then the vertical part will also cause a clockwise rotation. So it's negative. It's sine of this alpha for the 4, so 4 sine. And then the distance is going to be, we're going to the bend, so it's just this distance, which is 1.5 cosine beta. And there it is. And then, of course, plus the response moment. And if you add all of those up, we should get 0. And it uses all my numbers, so we did get 0. So that's right, and that does agree with the back of the book. But again, there's ambiguities a little bit sometimes in this one, so I think he just says 3.46. You can't really tell. He really should have called that a minus. But you can see that it checks. So that is number 510. If you have any questions, shoot me an email.